Okay, Assalamualaikum to all of you. So due to MCO, so we have to continue our lecture online. So I have to record some of the lecture notes. So make sure you print your lecture notes. So then we continue chapter 3 part 2, that is triple integral. So I already taught you some of them on how to integrate. Okay, for a constant. So now I will show you limits are not directly given. How to integrate if the limits are not directly given. Okay, for non-rectangular solid, you have 6 different ways. Okay, so that is type 1, integrating over simple xy solid. Type 2, integrating over simple xz solid. Type 3, integrating over simple yz solid. So type 1 you can do in 2 different ways. That is, you are integrating f, let's say I put w, that is function xyz, dz, and this dA will be dx dy. Again is the same. Integrate w is a function of function of x, y, z. This will be dz, but dy dx. Remember, this is constant x, constant at y, constant x. Constant at y means type 2. Remember, in double integral. And this is constant at x means type 1. Okay, so for type 2, so another 2 ways, that is integration of w, but now will be dy, and this dA will be dx dz or dz dx. Okay, same integration of w, dy, dz dx. So over a xy solid, so here over xz solid, which means you have dz dx dz or dz dx. So over a simple yz solid, which means you must have dy dz or dz dy, which means you are now integrating your function dx. So we have 6 different ways to represent triple integral. Okay, remember this z is function of x and y. This y is function of x and z, and this x is function of y and z. Okay, we do some examples so that you can understand. You see example from the notes they given you. So please see the notes. Example 1, let G be the wedge. G is the wedge in the first octant. In the first octant. First octant means like in a first quadrant. Okay. So we have 8 octants. So this is the first octant, which means it's in front. Cut from the cylindrical solid, y squared plus z squared equals to 1 by the planes y equals to x and x equals to 0. So evaluate. They ask you to evaluate triple integral at solid G z dv. Okay, they ask you to find this. So again, you can use any type 1, type 2 or type 3. Okay. Okay, let us see. First, the step is you have to sketch the solid, which means you sketch the surface. Check the solid lines on the wedge region and then sketch the region area as in double integral. Okay. Choose order of integration type A, 1, 2 or 3 or 4dA double integrals. Find the limit for dA, then limit for the third integral. Okay, see, we sketch the solid first. So if you see this, if you have all squared and you have only 2 variables, which means these are the cylinder. Okay, and no x is missing, so parallel to x, but this is in first octant. So it would be like x and this is y and z. So let's draw the negative ones. So somehow should be okay, your cylinder should be parallel to x, but only in a first octant. Okay, so another one is y equals to x, which means this is x, this is y, so somehow in between here. Okay, so this cylinder is a curved cylinder. So if you cut in y equals to x and the one x equals 0, which means here, so it will transform to, so I put y equals to x here, x, y, somehow it is 45 degrees from the x and 45 degrees from y, z, and then you have a curve. Suppose it's a cylinder, so maybe the half curve is here, but we don't consider. We really don't want to consider. It should be like this. Okay, so that you can see. Then we have x0, x0, y equals to x, okay, so we draw another one here so that you can get exactly the curve. Okay, so if I draw back again, it will be like sort of one here. Okay, another one is here. So this is the region where y equals to x. Okay, so this is the region where y squared plus z squared equals to 1. Okay. Then your x equals 0, which means here. So because this is y, this is x. So actually it is here, but it will be the whole z and y. X0 means 0, y, z, which means the whole here behind will be x equals 0. Okay. Okay. Now the lower bound here is x and y, xy solid. Okay, we call them xy plane. Better we call them xy plane. So for sure it's a plane. So we can use type 1. You can use type 1. So they ask you to find integral of g z dv. Okay. If you want the type 1, this will be z, it's okay. This will be dz dx dy or dy dx. It is okay. You can use any type of here, type 1 or type 2. So I just choose dx dy. So this z, the bottom z here equals something to z equals something, like double integral also. This is x, the second one should be x equals to something, which means the lower bound to upper bound. Y equals the lower limit, y upper limit. Okay, so this z should be at the bottom. The lowest bound is be 0. So the upper bound of the z, how to find the upper bound of z? They given you y squared plus z squared equals to 1, which is here. So your z should be plus minus 1 or minus y squared square root. But they given you first octant at the question, so you have to choose the positive one, which means here is square root 1 minus y squared. Okay. Okay. How about dx dy? How you want to know x from where to where? So better you draw back this. So we have, let's say I put in 2D y x. So for sure we have something like this. Okay, so they are cutting in y, so you have to draw here like this. So this is the region. So this is 1, here should be 1 because this radius 1. Okay, so here I think 1 is here. We cut at y1, so this is y equals to x. So dx dy mean we cut at y. Remember this, cut at y. So your x should be 0, 0 to y. X should be 0 to y. And then your y should be 0 to 1. Remember, the outermost integral should be constant, cannot be a function. Usually this z is function of x and y. At least we have y. Okay, then your x should be function of at least y. So we have one y, but not z. And then your y should be a constant. Remember that. Okay, they are reducing. Z is function of xy, x is function of y is constant. Okay, now you can integrate this easily. So remember, integrate the inner part first. So integrate z dz will be z squared over 2 from 0 to square root 1 minus y squared. So we have to integrate another 2 times. So this will integrate another one, 0 to y, 0 to 1, dx dy. So we have 1 minus y squared half and then 0 is okay. That you integrate this, this is dy, respect to x will be, we just add x, right? Half x 1 minus y squared is a constant, so your x is from 0 to y, 0 1 dy. Then you have half 1 minus y squared is a constant, so x is y. Then integrate the whole thing respect to dy. So to integrate this, you have to expand first. So if you expand this, you have half y minus y cube from 0 to 1. Then you have half y squared over 2. This is y squared over 2 minus y4 over 4 from 0 to 1. Then you have half 1 over 2 minus 1 over 4, which is half. So this is 2 over 4 minus 1 over 4 will be 1 over 4, and this is 1 over 8. Okay, so similar, if you like integral, the integral by integrating first with respect to x, which is type 3. Here is dx over the surface dy dz, or dz dy, no problem. Type 3. So if you choose the surface dA is dy dz, dy dz or dz dy, so try to see in zy plane, because dz dy is in zy plane, so which is quarter circle. So this is y squared plus z squared equals to 1. Here should be 1. Here also should be 1. And this is zy plane. Okay, this is the region. So again, we can integrate easily. The question is z, and then we choose type 3, which is dx inside. The outermost can be dy dz or dz dy. I just choose dy dz. It's nothing wrong. So now you can see what is the x. So x is from, you have y equals to x. Okay, they already given you, and x is 0. So for sure your x is 0 to y. Again, the x should be function of yz at least. Okay, and then you have y is from see the here. Now z is a constant because z is the outermost. Then you have to slice on z, and then what do you get now? Your y is from here, y is 0, so 0 to y. So y should be plus only, because first octant 1 minus z squared. 1 minus z squared square root. See, your y must be function of z only. Then your z should be constant, that is 0 to 1. Okay, you can integrate the same, you will get 1 over 8. Please check. Okay, maybe your homework. Okay, so let me give other example. So we are practicing to find the limits. So there are 6 different ways, like usual. I will show you. Okay, you can see the question 2. Limits are not directly given. They give you, sketch the solid bound. Slide 16. Try to see slide 16, question 2. Limits are not directly given. Sketch the solid bounded by the graph of the given equations and express triple integral f x y z function of x y z dv as iterated integrals in 6 different ways. So they ask you in 6 different ways, which means type 1, type 2, type 3. So each type we can switch the dA. The dA means, let's say I put dz here. This is dA. So your dA can be dx dy or dy dx. So this is type 1. So if type 2 mean, here will be dy. The same integral dA. So your dA now is dx dz or dz dx. Type 3, you are integrating dx dA. Your dA is dx, this is dx, so dA will be dy dz or dz dy. So it is better to sketch this first. Easy. It's up to you. You want to choose type 1, type 2 or type 3. Look, this is dx dy. Dx dy, when you see the base, when you put your eyes above. Okay, dx dy. Dx dz, try to draw. If you can't see, try to draw. This is z, this is y, x. So dx dz is here, right? Somehow it is here. Okay, let's say I have a line. If I have a line, just draw again. So dx dz, if you put your eyes here, okay, dx dz, dx dz dx. If dy dz, it is here. If you put your eyes is in front, dy dz, okay, is at the back. In front, put in front and back. Dx dz will be a side, and then dx dy will be bottom, above and bottom. Okay, above and bottom. Dx dz will be side. Say I put another one here, side, and then dx dy will be above. Okay, so we have to able to see, able to recognize. Okay, they given you x plus 2y plus 3z, so 6, x equals to 0, y equals to 0, z equals to 0. Okay, so x0 means everything y and z, and your x is 0. Y0 means everything x and z, Z0 means everything xy is Z0. Okay. Okay. So from this equation, you can express in 6 different ways. So let's say I choose xy plane. Okay. I choose xy plane. I'm sorry, I think it's already overloaded. I have to open again. So xy plane. So xy plane means your z equals 0, right? So z0 means x plus 2y equals to 6. So from here I can draw a line which is y and x, and then when x 0, I think y is 3, and then when y is 0, x is 6. Okay, so if I move here, this is 0 when x 0, and this is x plus 2y equals to 6. But I can write this x as (6 minus 2y), or I can write this line also, this line as y equals to 6 minus x over 2. I just make it this x as a constant or this y as a constant. Okay, remember that we have dx dy, we have dy dx, that's why I just ready. Okay, I know here always x is 0, here always y is 0, because this is x axis and this is the y axis. Okay, so you can integrate directly using this, which is type 1. Okay, so they are referring to xy plane, so which means you can integrate triple integral, so f function of x y z dz dy dx. So this is xy plane, this is dA means dy dx or dx dy, or you can integrate the same thing dz, but now is dx dy, because it is in xy plane. Okay, so remember your z is 0, so you are given that x plus 2y plus 3z equals to 6. So your z should be 6 minus x minus 2y over 3. So here it should be 6 minus x minus 2y over 3, the upper limit of the z. Your y, so now y is depend on type 1 or type 2. Here is cut at x, just here. So x is from 0 to 3. Is it? No, your x is from 0 to 6. How about your y? Your y is from 0, yes, up to here. Your y should be 6 minus x over 2. Okay, for this, in this case, it's the same. Your z is 6 minus x minus 2y over 3. Your x now is type 2. So x is from 0 to 6 minus 2y. Now your y is 0 to 3. So don't be confused. Be sure. Okay. Okay. So you may ask why I didn't draw a full diagram. So it is just the same. I will show you. So already xy plane. Now next is type 2 will be xz plane. Xz plane. Xz plane. Xz plane. So xz plane will be y0. So from that equation you will get x plus 3z equals to 6. Your z equals to 6x minus x over 3. Okay, from here you can draw another plane. So when x is 0, zx, x is 0, z is 2, and then when z equals 0, x is 6. So this will be z, so 6 minus x over 3, or x equals to, if you put x as a subject, will be 6 minus 3z. Okay, just rearranging this equation. Okay, so again, as a question asked in six different ways. Integration of f x y z dv. So this we have another 2 here, already 2 and another 2. That is, this is type 2, so inside should be dy, okay, and dx dz. So if you choose dy first, so you have to cut dx. This is y equals something, right? So this is from 0 for sure. They given you from 0, and then from the original equation we have y equals to something. We have to choose y equals to something from here. So y is 6 minus x minus 3z over 2. Right? So like here, y is 6 minus x minus 3z over 2. 6 minus x minus 3z over 2. So another one is same. If you put here dy, dz, dx also, the first integral will be 0 to 6 minus x minus 3z over 2. So now the second one and third one will be different. So your x, this is cut at z here, z, which means your z is from 0 to 2. The middle one, x equals to something. Your x must be a function of x, z. So your x 0 to 6 minus 3z. The second one, your x is a constant, which means your x is 0 to 6. 0 to 6. Your z should be 0 to 6 minus x over 3. Okay, so you can integrate easily. So we have 2 for another 2. We have xy plane, xz plane. So another one is xy plane, yz plane. we have YZ plane, which is x equals 0. Okay, so when x was 0, the equation will be 2y plus 3z equals to 6. So your z is equals to 6 minus 2y over 3. So you can draw another line. So when y is 0, z is 2. When z equals 0, y equals to 3. Okay, so in this case, you can integrate here will be you have dy dz, here will be dx type 3. Okay, so your x is 0, 2. The original equation will be x plus 2y plus 3z equals to 6. So your x should be a function of x and z, y and z, sorry. So your x is 6 minus 2y minus 3z. Okay, so your y. So dy dz means z is constant, so cut at z. Okay, so cut at z, your z should be 0 to 2. And then this is z equals to 6 minus 2y over 3, or can put as y equals to 6 minus 2y over 3, right? Okay, so this is from 0 to 6 minus 2y over 3. Or another way is you put dx here, dz dy. So again this is same, 6 minus 2y minus 3z. But here your z is cut at y here. So your z should be 0 to 6 minus 2y over 3, and then your y is from 0 to 3. Okay, so if you join all this, you will get somehow we have z y x. So this is I think 2, and then we have 6, and this is I think 3. Because this is a triangle, I can see this is another triangle, another triangle, another triangle. This represent yz simple, this is xy simple, and this is xz simple. Okay, type 1, type 2, type 3. Okay, hope you can understand. Then go to question 3. Limits are not directly given, they give you volume. I think they ask you to find the volume. Volume means your triple integral should be 1 dv. This is volume. So A, evaluate the triple integral. So you can choose either type 1, type 2, or type 3. You can use any type. So again, this is just they give you x equals 0, y equals 0, so which means this is the starting point, z equals 0. Then they give you 3x plus 6y plus z equals to 6. So So I think this is easy. Okay, easy than curve. I think the first one is a curve, which is cylinder and plane. Now this is just a triangular shape. So I think I just leave this to you. I proceed to B. Okay, the A answer is 2. Try to find it. 2. So now I want to show you 3B. Question 3B. They give you Z equals to Y. Okay, Z equals to 0, X equals to 0, X equals to 1, Y equals to -1, Y equals to 1. From here you can see this is parabola. So this is only the curve and start from 0. This is a plane, this also is a plane. Okay, a plane with parabola. Okay, we see here, I try to draw first. So when Z equals to Y, X is missing. So it is project to x-axis. Okay, remember. So try to draw first. Okay. Z equals to Y. So see, Z and Y axis. Z and Y axis, Z equals to Y squared. Which means you have to draw somehow. My drawing is bad, but I hope you can accept. Okay, so it is project through X, so you just draw another one to X. Okay, so you can draw a longer or okay. Then you have X equals to 1 and X equals to 0. X equals to 1, X equals to 0. So X0 is here. So let me put X equals to 1 is here. Okay, Y equals to 1. Here, Y is -1. Here. So you have a box. You have a box. So this is y1, y -1, x1 and x0. Okay, so this is the region. It's just like you have the hole here, so like a drain. Longkang. Longkang is in Malay, drain in English. I'll continue for a while. Okay, so let me choose type 1. So type 1 will be volume triple integral 1 dv, okay, which is f x y z should be 1. So your dv will be dz, which is triple integral dz. I just choose type 1 here, dx dy. So the bottom part, projection on xy, remember your eyes is here, so you will get somehow this is y, this is x. Remember your y is, your x is 0 to 1, your y is negative 1 to 1 as mentioned. Here is negative 1, here is 1, 0, this is 1. Okay, so now this is your region for dx dy. So I just draw this first for make it easy. So your z as given from 0 to y squared is easy. So your z should be a function of x, y, at least one variable or two variable. So your, now this is dx dy, which means you cut at y. So your x is from 0 to 1, because it is just a rectangle, and then your y is negative 1 to 1. It's easy because it is just a rectangle. Okay, so I think you can do it this. So this is just a, inside one is just a z from 0 to y squared, 0 1, this is negative 1 to 1 dx dy. I just choose dx dy over integration over dx dy because this is simple. It's very simple because the bottom part is only the rectangle. Okay, then this is y squared, and then you integrate respect to x, you will get x your x from 0 to 1, so it's just y squared, then you have y cubed, integrate again, get y cubed from 91 to 1, then you have 1 over 3, 1 minus 1, then you have 2 over 3. Okay, question 4. So question 4 regarding the same concept. Question 4. In question 4a, 4b, sketch the solid whose volume is given by iterated integral. They ask you to sketch, but they give you negative 3 to 3, negative 9 minus x squared to positive square root 9 minus x squared, and then 0 to y plus 6 dx dz dy dx. So this is the bottom part. Y represent this, which means you can draw your x, sorry, this should be, the question given is dy dx, sorry. Okay, so your x is given from negative 3 to 3. Okay, your y is negative 9 minus x squared 2 positive 9 minus x squared. z from 0 to y plus 6. Okay, you can see here, this is a constant, this is a plane, and this somehow is like a circle. Okay, from here, let's say I choose plus minus, okay, as given. If I square both sides, I'll get square, and this is nothing but circle with radius 3, and then for sure this is plus minus. Plus minus 3. Okay, so this shows somehow z is missing, so a cylinder respect to z axis and project to z. Okay, so if I want to draw this, I draw a circle first. Okay, remember to draw this 3 should be smaller 3, because then you can get a nicer shape. So I extend this, and I choose -3 also, and then I have at the behind part -3. Okay. It's a circle, actually it's a circle. Okay, this is -3. You should draw the axis smaller so that you can draw nicely. Okay, and then I have z0, which means it's already z0. Then z equals to y plus 6. X is -3 to 3. So -3 to 3 is already done. It's automatically here. -3 to 3. Here is 3, is -3. Displaced. And then x is done, y is done. Now it is project to same axis, but we have z equals to y plus 6. Okay, now it is z y plane. So when y is 0, z equals to 6. Okay, and then let's say when y is 0, z is 6. When y equals to -3, I just choose -3 because it is bounded here and here. -3 z will be 3. When y equals to +3, z equals to 9. So what I can do is, this is a slice part. They are slicing. If you plot this z and y, what do you get? You will have 6. When y is 0, z is 6. And then when y equals to -3, you will get z equals to 3. Then when y equals to 3, z equals to 9. So somehow it's a slice. So you can imagine that there are something sliced over here. Okay, there's something sliced here. You see, when z0, the y is -6. So we have this. We have 6 at z, and y is negatives here. So something they are following here, but it is still a circle. A plane slice off a cylinder. Okay, projection of x squared plus y squared equals to 9. This will be to z axis. Okay, so it's a slice. Okay, done. They ask you to plot. They ask you to sketch, only sketch. Another one, B, 4B I think. Okay, 4B will be into triple integration. They give you the limit, they ask you to sketch. dz divided by x. Then we have x squared here, 1, negative 1 to 1. So x is negative 1 to 1. Your y equals to x squared. So something is a parabola, which is half cylinder, y equals to 1. And then we have x and z. Okay, z is 0, from 0 to z. Okay, remember that this is just a half cylinder, this is a parabola, and then this is a constant, and this is again something gonna slice this curve. Okay, remember that. So let us draw 3D. Okay, this is z, and this is y, this is x. Okay, negative x, so negative y, negative z. Okay, so x1, negative 1. Okay, let's say I choose here 1 and negative 1, just take a bigger size. Then y equals to x. See, y equals to x. This is y and this is x. So somehow you will get, you see, if I plot y x, I will get this. Okay, so now my y is this, x is this, so I have to plot somehow like this. And then in this case z is missing, which means this parabola projecting on z, so it will be somehow here. But we have z0, which is again from here 0, 0, 0, 0, and 1 minus y. Okay, try to plot 1 minus y, z and y. Okay, so when z0, okay, I think I put here z0, y equals to 1. Sorry, when z0, yeah, y equals to 1. When y0, z also equals to 1. So somehow it is here and here. So somehow you're gonna, it will be sliced like this. Can you see? It will be sliced on z equals to 1, y equals to 1. Okay, if I draw here, this is x equals to, they give you x91, y equals 91, x91 and x equals to 1. Okay, so I draw again. Okay, and then I know it is already project to z axis because that is missing. Now your z is a slice of 1 and 1, 1 and 1 here, 1 and 1. So which means they will a plane here, and then you have another one project Can you see it? This sometimes you have to draw more smaller. Then I have to draw more smaller so that you can see. Actually, I choose one is smaller so that you can see. Okay, let me draw again so that you can see. So you have y equals to x. So this is y, this is z. X, negative x, negative z. So let's say I draw more smaller parabola so that you can see this is y equals to x because this is x and y and parabola. More smaller, then you have one here. Should be a curve, and another curve is here. Okay. So you can shade here also. Okay, so in this case this is x and this is x equals to negative 1 to 1, and then this is line that 1 1. Okay, okay, actually this is the thing, and then this is a line slice out, that is z equals to y plus 6. Okay, we finish up this. Next class we will move to cylindrical coordinate. Goodbye.